All right, I'm starting the stream, everybody, because I'm going to start off.
Well, basically, we do something kosher and we do some sausage. Because you get some things you can only do that what you really want to do is
All right. I think we're live. All right. Welcome back, everybody. If it's Friday, it's a good day. It's Bayesian. Let's go. Before we start off, I feel like class is taken, after grading the homework and talking with a few of you, I feel like there's like this aura of stress involved in class, and I don't want that to be that way because there's nothing that we need to stress out about this. I'm going to be, like, I want to be your biggest supporter about everything you do, but in education, I have a strong belief that we need to have, even my watches tell me to relax. We all need to, you sort of have a learning process, this sort of trial and error, and I try to structure the class where you don't get penalized for the errors, because you can try again. That's the whole purpose of it. So let's start off with something a little bit lighter, shall we? This is something I found on Reddit. This is data visualization.
Oh, I love this one.
So this is the infinite hog supply. This is a map. I don't know when this was created, but here's a picture of the United States, and each dot represents 5,000 hogs. And I love the comments. Right. First one: untapped infinite hog supply. Second: each state is lined with an impenetrable wall of swine. We are trapped. And then we've lost Canada and Mexico to the hogs already. So I think this is great. It sort of relates to data and how to like make plots. Although this has got to be, look at the typesetting of that. It's got to be like 1940s.
They didn't have colors back then.
Yeah. So anyway, I love the Reddit. So let's go to talk a little bit here. Let me get my notes out. So first thing we're going to talk about is the homework that I had just returned that was graded. So a couple things about the homework. First, you may hate me because of how I graded it, but my goal in grading it was not to make you feel bad. It was to try to get you to see how I view text or how I view analyses or how I view whatever else. And in particular, this is a topic that's come up. Lisa and I worked in a few campuses, worked with a few grad students, and it's always the case that, particularly in the quantitative methods programs, it's really hard to get enough writing experience and practice until you've until dissertation stage. So a lot of times, a lot of the people that we work with really struggle trying to write a dissertation. And what I like to say when I admit students, I'm not worried about your math ability because I can help you with that. I'm worried about your writing ability because to get out of grad school, you have to be a writer. You have to write a big book effectively, or multiple books to get out of grad school. So my goal in getting you to write, even if they're little blurbs, even if they're 300 and 500 words at a time, is to try to get you to think about that. And then that's part of the reason I took your documents and compiled them into Word so that I could try to make comments or track changes or edit them so you could see where those issues showed up in your writing. It's still hard. It's still hard to, and if you don't have a lot of comments or issues, that's cool too, right? So you still need practice. The only thing I know about writing is that you have to do it constantly to do it well. Let's see here, and hopefully get a little feedback now and then, right? So you have to keep practicing, but then get feedback. So the grades that you saw were based on mainly two things: writing issues, and then issues with how we modeled data. That's the big picture. So how are we feeling about it? Writing, if any comments I made were unclear, let me know. I don't have the chance to sit down with you individually and write, but Lisa and I talked about this recently. There's been some formative times when I'm learning how to write, right? Many of you are dealing with a problem I've never had to face, which is I'm a native speaker of English. It's still incredibly difficult to write technical stuff, right? So those of you who are learning English or English is a second language, that's even harder, right? So I can empathize. That's difficult, incredibly difficult. But one of the more formative times I've had in my life, and then also seen with a couple students, and Lisa's students as well, is that I remember, I don't know how to teach writing, but I remember sitting down with several of my students before and being like, here, let me rework your intro of your dissertation a little bit. And this is why I'm writing. Watch what I'm doing. I'm thinking aloud while I'm trying to type. And I found that, they said that was incredibly helpful. I don't have that opportunity for you, but I'm hoping my comments do some of that. The other part is, if you see pattern in the comments, or in the edits, sometimes, there's a lot of non-native English speaker writing things that happen, like paying attention to tense, verb tense, and paying attention to like plural, having definite or indefinite articles leading to certain words. It's tough. English is a ridiculous language, so I totally get it. I'm trying to learn other languages too. I admire Ariel and a visitor from Spain. She speaks Spanish, right? I want to speak Spanish. I want to be able to do that. I'll never be able to do that, right? It's really hard, but that doesn't mean we can't try to work on it while we're trying to do this too. Now let's talk about, okay, so now I'm off the part that I'm really on shaky ground on, because I'm also an aspiring writer as well, right? Let's go back to something I feel a little bit more solid ground. Let's talk about the models. The model for the variance was the thing that really tripped us up the most, and there's a number of you that tried to put the model for the variance in where you did the analysis with a homogeneity of variance assumption, and you looked at residuals to see if the variance differed. And that's not, I would write in your document, that's not sufficient evidence for making a claim about whether the variance differed. What is sufficient? Because why is it not sufficient? Let's talk about this one. You're eyeballing a test. It's subjective. It doesn't have a number associated with it. So the part that I was hoping to try to get you into with that is to do the location scale model approach, right? What does that mean? That means I want you to model the residual variance as a function of the group variables. Now, I provide an example for that. I think it's lecture 7. If you go download, look at that. I put it in at the end of a class one day. But why I want that to happen is it's sort of a philosophical thing. There's a lot of things that you need to understand that you've learned about models that you've been told those are the assumptions. These are the rules that aren't really the rules. And I want to break those down for you. There are the rules are the ones that you set for your model and for your analysis. And so if you want to go and test homogeneity of variance, put in model parameters that try to do that. Now, in our case, it's much more simplified because I'm only looking for homogeneity variance across group. If we were trying to look for some nonlinear function of variance, or if we put in one of the continuous variables, it would be infinitely more difficult, mainly because the trend of it is most likely not linear. And then now we're into, okay, now what do we do? Let's not, I'm trying to break that down, just let's not go there. Let's go with a step forward and saying, hey, we could do that. The other part I want you to see is that in the Bayesian analysis, or when you're doing an analysis where you have to specify the model statement, you have to specify the distributions that are involved in that, you have the control to put any assumptions you want into the analysis. And I saw this, I remember being on a dissertation committee at Kansas. This is a person who now works as an engineer at data scientist at Apple, right? So it's an interesting place to go after school. But they were testing some type of diff. They were doing some type of diff study for their dissertation. And the model they had come up with had the homogeneity of variance assumption in part of it, where it didn't have to. It was just a quick switch, and it was pretty obvious that most data probably didn't hold for it, what that was. But in the model code, it would be as simple as, simple, but it would be as a few characters as taking that variance parameter, saying it's equal to the e, or it's raised to a power of some function of parameters. So it's always important to me to think like this tool, or this set of, when you do analyses, Bayes is one way. You can do this in Proc NL Mixed and SAS. You can do this in all sorts of other places where you basically have to construct the model line by each part. That gives you great power to do that. And effectively, we have these great conversations, my colleagues and I, these two in particular, about how we would teach things differently, knowing what we know now, instead of starting with the history of how we taught things now. And this is sort of this running dialogue I had said, would we call homogeneity of variance in ANOVA an assumption if we had the ability to model it back when it was created, right? So it's one of the big questions. So does that make sense? Any questions on that? So, to be more specific, for the variance, residual variance, to make a claim about research question 3 that says, are the residual variances significantly different across groups? I'm looking to see that you take the variance parameter, right, set it equal to like a regression line, right? So you start with the logit, a log. Log variance is equal to a regression of each of the, so it has an intercept, it has a regression weight times each of the group variables. And then you take e to that thing and put it in the variance part of the JAGS code that goes with it. That's the main picture. So then, once you do that, you have essentially 4 parameters describing residual variance. How do you tell if the residual variances are constant? It's harder in Bayes. You don't have an omnibus test. The way I like to think of it is, if you look at I like to take the highest density posterior interval, HDPI, and if 0 is contained in that interval, then you can effectively say, let's take a 95% HDPI or a 99. If you see a 0 in that interval, you can say it's plausible this parameter is 0, right? It's sort of centered around 0. So for each parameter, you can say that, but across each of the group parameters, the 3 that involve the group, if any one of those does not include 0, you have evidence to suggest there is some type of heterogeneity in residual variance. How's that sound? Cool? Okay. Yeah, Ben.
I don't think I ever received the graded homework.
Oh!
I got the homework grade, but not the graded homework.
Interesting. I tried to send you an email with it. No? No? Okay. Can you send me an email? I tried to send everybody emails back. If I missed you, I apologize. I have it all graded. I will send it to you after class. But please send me an email.
I was like, is he keeping it secret for a reason?
Oh, no. That's the thing. I sent it out on Tuesday. I thought I sent it out on Tuesday, but anyway, I switched my email system over, and I thought I had sent it out to everybody, but evidently didn't. So, yet again, a senior moment. And I'm not even technically a senior yet. Okay. Sorry. That frustrates me about myself. So anyway, long story short, when you get those, if you haven't seen it before, take a look for those things. The other part is you have a chance to resubmit the homework, and I have a deadline of that next Friday, like sometime next Friday. Most likely, it's not going to take you a whole lot of effort to change. What I sent back to you, each of you, is a Word document that compiled your R Markdown, and I tried to make comments into each of and so keep that Word document and send that back to me. You can make changes on the Word document. You can accept my changes. I did track changes for some of the like the technical grammatical problems I may have seen, but I made comments on other ones. Just leave my comments, keep track changes on. You can accept my changes, that's fine, right? So that way I can see how you've improved it. But then you can describe, you can change the model part. You can just change the results section effectively. You can paste in your code if you have to, or you could just change the model in your R syntax and then paste in the results. Okay, questions? Yes.
I had issues with window.
Window, yes. Oh, thank you, Katie. Anybody else hate the window command? You know what window is? So window is the command that takes the Markov chain and truncates part of it, right? So for instance, this is the file for lecture 9 today. After we run analysis using JAGS with a code of samples function, that analysis does not trim off burn-in period. So to trim off the burn-in period, we have to use this window function right here. And we tell it where we want to start and where we want to end. So when you submit the part that includes your entire posterior, your entire chain after adaptation, then what it returns is the part that's within this start and end. And where this can happen, I know a couple of you have talked about this last week as well after class. What can happen with this command that drives me nuts is that if you, let's say you run code of samples and you tell it some number of iterations and you're like, oh wait, let me go change that. Just run it again. Maybe I had 100 here, or maybe I had 1,000 here, or whatever, and I really want to make it 10,000. So you put in 10,000 here, do it again. That first code of samples object updates your model with the chain values such that whatever you ran before is now the starting point. So if you ran 1,000 and you say I'm going to now run 10,000, it's going to be from iteration 1001 to iteration 11,000, because that first 10,000 that you ran before is now updated in that object, which is frustrating because you don't see it being returned, right? And so that means when you come down here to samples, if you say your burn in goes from, if your burn in all of a sudden is outside the range, you'll get an error. So to circumvent the window issue, you have to reset your model object. And because I'm still not sure if JAGS resets the random number seed, I typically go, just in case, reset my random number seed part right here, and then rerun the analysis with the JAGS.model syntax that builds the model at first. Right? So I have to recompile the model effectively. And because there's stuff going on that's not transparent, and I'm really paranoid and I really want you to save your random number seed to have reproducible results, basically you have to start over with the random number seed part, which is in the init section, then do JAGS model, then do code to sample. So it takes this process. Is that alternatively, you could change your burn-in. That's the other part of it, right? If you know the range of where the parameters are for the start and end, you could also change your burn-in on window and just take the last part of it. But then you have to remember, you have to be able to report how long the chain was when you did that. I don't like that strategy as much because the reproducibility of that result is less there because you have run sections of code multiple times without it being in syntax as well. So.
To be sure that I follow, yes, I ran into this problem in the past and I never knew why it was happening. So it's like, oh.
Well, there may be multiple reasons, but that's the one I have run into, yeah.
So you just change your seed and go back to from the beginning?
Yes.
And that will override whatever object was having your previous iterations.
That's right.
Okay.
Yeah, when you run this section of syntax right here, that section will overwrite the model object. This object contains all the information that JAGS runs. Because I don't know the relationship of it to this model, this init value is where the seed is held. I go and reset the seed just to be sure. I guess I could probably check it, but then it's difficult. It's in multiple chains and it's a pain. So, yeah.
Maybe.
Thank you.
We can. I'm wondering whether we can clean the environment.
You can. Yeah. That would also do if you go up and make your environment empty, or use syntax to do that. That will also destroy the JAGS model object, and you can start over again as well. Although cleaning the environment, you may have other things in there that you might not want there. Alternatively, you could remove just the JAGS model object from the environment, and it would do the same function. It's frustrating. And this is part of the reason that Bayes is slow to gain traction, because it takes a lot of code and understanding of what's going on, and then stuff like this happens. Like, why am I using rJAGS instead of R to JAGS? Because I can't get R to JAGS to reproduce my results. Right? Well, I don't like that. My idea of, if somebody wants to double check your numbers, or you want to double check your numbers, right? Let's say you work on a manuscript and you submit it, and you've got results in there, and then you get a revise and resubmit because of reviewer 3, right? Or in my case, it's usually reviewer 1 and 2 as well. Sometimes the associate editor. So,
And sometimes Lisa's just like, come on, man.
seriously, what a fraud. What a fraud. Fraud Templin. But what happens is, when you go back to that manuscript months down the line, for me it's like many months. Evidently, the rest of the world runs on a different speed than my papers take when they're under review. And you start to look at it, and they want changes to your model or changes to whatever else. The first thing I typically do is, okay, what did I do? They grab the data, grab my syntax, rerun things. If you don't get the same result that's in the paper, even if it's changed a little bit, that's frustrating, and that's actually a hard part to start. So that's where, I really, really want to be able to control what comes out of the analysis. So that's why I don't use R to JAGs unless I'm getting sick of writing all this code for everything. So, questions? Thank you, Katie. Okay. Other parts about homework. One of the things that in the write-up that I also constantly saw, and it's mainly a function of not really knowing what goes on in Bayes. But if you think of when you write up a results section in a non-Bayesian context, of using maximum likelihood or otherwise, whenever you report something happened, right? You have a table of results, but typically you pick out numbers from the table that are important, right? The difference between these means was 2. Almost invariably with that 2, you provide some other type of information about the certainty of that prediction, right? You talk about a p-value, you talk about standard error, you talk about something that goes with it. And in Bayes, it's no different. It's just hard, what do you pick to say that? And I think the thing I like to see afterward, I wrote in each of yours one of the posterior, either the credible interval, like a 95% credible interval. Like, so you can say the difference in mean was 2 in parentheses, 95% CI, negative 1.5, sorry, 1.5 to 2.5. Alternatively, you could use a posterior standard deviation, right? That would also describe it, although that doesn't necessarily show the shape. I kind of think the better indicator of the certainty of your statement is an interval that would sort of say that. Questions? Let's see, I almost thought I saw it. Thoughts?
That makes sense.
Yeah.
I think it was hard for me. I want to keep using the word significant.
Well, that's what I do too. Yeah. And it's tough because it's like, well, we're fairly certain that this is not 0.
Yeah, it was something like that.
Exactly, and you sort of have to dance around that, which is tough because in a typical article you feel like you're much more direct.
Yeah.
I would, because it's such a charged topic, and if you get a real, super Bayesian person who reads your article, they're going to be like, yeah, don't do that.
Yeah.
You have to sort of avoid the word significant and say otherwise.
I mean, even if you're being reviewed by like a frequent test,
yeah,
put in a confidence interval, people know what confidence interval is.
That's exactly, and so you're speaking a language that would be, basically you're trying to provide certainty to the point estimate that's providing your data, your claim, right? You're saying these means were different. Here's how the average difference was, the EAP estimate, right? It's just one of them that you could use, and here is the certainty I have to it.
Can you punt on that? So here's a situation. Let's say you're writing an article in which you were forced to use Bayes. This hypothetical situation, by the way, for an audience who does not care about your methodology one way or the other, right? They just want to know what the findings are.
Mm-hmm.
It's the journal of we specialize in this weekly. And can I say something like estimates for which the confidence interval, or not confidence interval, but a credible interval does not include 0 are labeled as significant below. Can I just say that once and then say something?
I'm pretty sure you'll get away with saying that.
Okay. Now in the journal of People Don't Know Better Weekly, I can say that, but if
I don't like it though.
Okay,
I could say you could say anything that was, you could just say was different or was was likely to be different. I think you could say significant but in different terms, caging it in certainty, because that's what a lot of statistics is about, certainty. Even the significance language is certainty, right? So if you cage it with this was meaningfully different, or
Well, it's
the
one like
Bayesian
this-
equivalent.
This predictor was related and this predictor was not related.
Yeah, that's fine.
So I mean that's the context in which you're trying to say.
That's exactly right, and you could say that, but not significant.
Well, so that in the same paper, I had an issue with the reviewers not understanding the labels for the headings.
Mm-hmm.
So for the parameter estimates, I used mean and SD,
Mm-hmm.
and they're like, mean of what?
So you have to really put EAP. EAP is like standard. It's like SAS.
But they were fixed effects. I mean, they're not like that's what it was like a slope, right? And so I was trying to figure out a way to like, how do I label the slope that came out of my bays?
You could say posterior mean, but that's a lot of characters. Really, EAP stands for posterior mean. Expected a posteriori is effectively posterior mean. The other way you could say is posterior mode, which would be MAP.
Yeah, well, it was a mean.
Yeah.
Can I say estimate and then like in the notes? say
Yeah, you can do
estimate?
that. Yeah, and the notes are your sort of your redeeming part of
Because
it.
no one's reading the notes anyway.
No, no, that would be fine.
Okay, all right.
Yeah, the point of the matter is somewhere in your text you have to leave enough breadcrumbs for someone to take your data and your script and get the same results. That's what I'm looking to do.
Yes, even though the reviewers don't want that extraneous information.
Not always, no.
That's the rub.
It's ironic. I'm outgoing co-editor of JEM, right? Thankfully outgoing. Not that I, don't regret taking the experience, but I don't want to read other people's work. I want to do my own work. I'd be happy to be part of the scientific community as a reviewer, but I think it's time for me to get back to trying to do more. The thing I saw at JEM was interesting because we started and we still had page limits for every issue that came out in the volume had a certain number of pages. So there was a contract that the Society, National Council on Measurement of Education, has with the publisher. Hey, publish our journal, X amount of dollars. We're gonna, whatever. And they said, okay, great. For X amount of dollars, we'll give you this amount of pages per issue, right? And then within the first year, they said, oh, we're doing away with all the page limits because pretty much we don't print any of these anymore. Who cares? It doesn't really. I mean, they do have printed versions of it, which I don't understand. It's like you get that for signing up to be part of the society. It's like, no, I try to override it and somehow forget that too. Anyway, so I do that, and then now it's like, well, there's no incentive to like cut down on page ranges, but readability suffers, right? So you have to sort of balance that, and that's where supplementary materials, online materials, things that you put on their own personal website, they're all ways that you can put additional detail into it. Most people aren't going to see it, but in the case where you may want to reproduce the research or someone wants to take a look at it or who knows what, it's there, it's archived. You had to do it anyway, it's just a couple more clicks to do that. So that was one thing about it. The next is, made my notes over here. The other part I noticed in some of the results, actually, any other questions on that? I should ask. Ben.
So I've been thinking about multiple comparisons a little bit, not a lot, so I sound stupid. In frequentist approach, right, if we're doing multiple comparisons, we want to control for the family-wise error overall.
Some families.
Right. So we make, in essence, then, each individual comparison more conservative, so you control for your overall nominal alpha. But it's not really the same thing with Bayes, though, right? And so I don't really need to make each credibility interval for my multiple comparisons more conservative because I'm asking, where's 95% of this distribution if this is where I think the parameter might be?
Right.
And that's all I'm doing.
I mean, yes and no, right? Because again, that certainty about the parameter has those error regions. Mm-hmm. And if you're going to say what's the likelihood that any of your parameters are outside of that error region,
sure, okay, yeah.
It still follows.
Yeah.
But yeah, I mean, it's sort of at that point, you have the quantification of the uncertainty that's there. Mm-hmm. I don't know. I'm less concerned about it. Worry about correcting p-values, but getting an accurate level of certainty is much more important to me. think Ariel has something.
So would you worry about getting your credible intervals? Will you adjust that?
You could if you were worried about it. I don't.
Well,
Yeah.
I want to say I don't think that at least in the scene that I read, I don't think I have seen ever anyone doing that.
I kind of suppose too, as it seems the scientific community is moving farther and farther away from p-values mattering, and so who cares about adjusting that? Like, here's my 95% credibility interval. You saw I did 4 comparisons. Draw your own conclusions.
Exactly, and you have. I mean, if you really wanted to do so, you could put the whole, the whole posterior distribution on a graph online, and people could say, all right, here's the graph of what you think it is for what you do. It's interesting, this conversation goes beyond just Bayesian, though. It actually speaks, Lisa and I were talking about this on the way home one of these days this week. And so I'm not a big fan of, worrying about the p-values after the adjustment. We also talked on the way home too. Because at some point there's some arbitrariness of it, right? At least you want to describe what you said.
Yeah. So you let's say you put a regression model together that has 8 predictors. Sure. Is anyone going to yell at you about type error, type 1 error rate, and family-wise error and all that?
Some families.
In one of that type of journal examples, I'm dealing with a reviewer that is accusing me of type 1 error because of that, and I'm just laughing.
So whereas if you have an ANOVA with 8 groups, you have 7 degrees of freedom that give you all of the comparisons, and the output gives you just the 7 you asked for, but you could ask for other ones. So why are the p-values that show up by default okay, but if you go in and ask for other ones, those ones are going to be errors if you don't watch out.
Oh, but the ones that the default ones are not okay either, technically.
That's my print. 1 and 20 is wrong. Whether they show up by default or not, whether they show up in a regression model or an ANOVA, there's nothing sacred about ANOVA and type 1 error.
Yeah,
That's
but
the thing.
and then so you trip over kind of the issue that shows up in one of the more famous Bayesians, if you read his blog, Andrew Gelman, he calls it p-hacking, right? Where you're trying to figure out, you're trying to find any result, and you're doing whatever you can to do it, or you're changing your analysis and so forth, right? The more you torture the data, the more likely the result is to be specific to that data set and not generalizable, right? We can all say that. This is not that case. This is more effectively saying, where do we draw the line? What needs to be adjusted and what doesn't? But the comment you made on the way home a few days ago was, well, I'm less concerned about adjusting p-values and more concerned about, if you violate the homogeneity of variance, what happens? Right? So it's like, oh, I can have a model fix on that. I'd rather get a better version of a p-value from a model than worrying about the overall p-value inflation or whatever else. So,
since you mentioned Gelman, I have to say this, and I hate myself for saying it. But he have a paper that made the argument that people shouldn't be hanging with P of 5. But he made the point that the difference between a result being statistically significant and not is not statistically significant itself. And he had a nice paper about that. He had that people make these deterministic conclusions because it's below 0.05 or it's right above 0.05. But really the difference between that two things is not statistically significant.
The 0.049 versus 0.051.
And it's a neat paper if you guys haven't seen it.
And I think that's it. I think that's the neat thing about the Bayesian framework that Gelman has significantly contributed to, and I don't mean that in a statistical significance case, is that really what we're talking about in all of statistics is a quantification of uncertainty, right? And so in Bayes, the way we do it, the methods are a little bit different, but we still need to provide that uncertainty estimate when we go and state our claims, because that's effectively how much credibility do you want to have to say things are the way you think they are. That makes sense. Is that good? So yeah, anyway, sorry, it brings up bigger issues. This type of analysis brings up bigger issues, but I guess the long story short, to get back to the answer, Ben, is I don't worry a whole lot about it. I'd rather list the HPDI. If you're really concerned, make it a 99.5% interval or something like that and call it good. the reality of it is, if you have a real strong effect, it doesn't matter, right? It's only for the marginal ones, and that's usually when, you know, who knows what's going on.
My last piece on this.
No, please, this is great. More.
To me, the being more strict about the cut point doesn't fix the issue around the threshold not being something deterministic and people make it to be. Because if you move it from, you know, this movement now to move it from 0.05 to 0.001.
Right, yeah.
And to me, the same problem. You're just shifting where you're creating the problem. Yes,
definitely it is. It really is changing. That big threshold argument is hard to see working. It's really just evidence and data. That's what we're trying to do. Anyone else I want to add to that or think about it? What we're trying to do with this is expand not just your Bayesian sense, but your brain that's not Bayesian as well. I learned a lot about not Bayesian by doing Bayesian. So.
Isn't that always the case in math? You learn the thing underneath it when you go on to the next topic?
Yeah, or actually for me, it depends.
You learn algebra when you learn calculus?
Yeah, that's for sure. I did. That was 100%. Forgot arithmetic, but algebra.
You learn calculus when you learn analysis?
Yeah, see, I haven't done that. Maybe that's my problem.
Now you're giving me numbers.
Okay, another issue that I saw pop up a couple times in homework. When you describe a conditional main effect. So what am I talking about here? Let's imagine in the analysis model that you had an interaction between group and, let's say, experience. I think that was it. And then you went and looked at the main effects of group. Now those are conditional variables, right? So that means specific to when the interacting variable, in this case experience, is equal to 0, right? Several of you in your description use the word held constant whenever all the other variables are held constant to describe it, and that is not correct. It's held the other variables could be held constant, but when you look at group differences, those constants go away. The issue is the interaction has to be held constant at 0. We just say, or experience is equal to 0, or I guess in our case we centered it at 4, experience equal to 4. So that's a really key thing in understanding the main effects. They're conditional on where the interaction value happens to be 0. So just remember that when you're writing things up. If you have a term that's a main effect that's underneath an interaction, worry about that. If you'd like more information on how to describe that, Lisa's website has lots of resources, and she's
Chapter 2 of my book.
in chapter 2 of her book is a good job too. Although, I mean, no, just kidding.
I never forget.
Yeah, I know. I was sorry. It's joking. Okay, so the last thing I wanted to talk about was an interesting thing that I saw. Each of you had an article to go look at. And I want to say 70–80% of you described that your article was lacking quite a bit of information about the analysis. Wouldn't you say that was right? When you read the article, some people talked about like chain length wasn't described. Priors, like a description of the priors, what they happen to be, not described. What did you think about that? This is discussion. This is not me trying to help you with the homework or picking on you with the homework, depending on which you believe. This is more discussion. Let's discuss this. And actually, before I say about picking on you with homework, I intend to give every one of you a full score on the revision. Right? I just want you to earn it. That's all. So there's no picking on you. I want you to get a perfect score, and we'll be done with that. But let's talk about that. What do you think? How many of you felt your article was lacking in detail that would help? Yeah? Yeah? Yeah. No?
No, mine was illustrating how to use Bayesian in clinical psych. So.
That would do it. Lisa, do you see this a lot?
Yeah, I think there's two alternative reasons why it's that way. They put the stuff in and some reviewer said, that's not related to your question, take it out. And the other is they don't know what they picked because they've said estimator equals Bayes or whatever other default was in the program and they didn't change anything. So they made a series of choices without knowing what those choices are and couldn't articulate them or didn't think they needed to.
Now, you do that all the time. If you think about running a maximum likelihood estimator, you've got to, if it's using some type of optimization function like Newton-Raphson, you have to make a convergence criterion. You have to set that. And nobody ever talks about that.
Because there's a default. You have to override it.
It depends on program. And the default changes from program to program, right? So what do you think needs to show up in an article to do Bayes?
Well, I think it could vary, right? Depending on your audience, depending on your question, depending on what you're analyzing. You know, in general, me as a reader, I like to know what priors are using because it tells me how they're thinking about the problem, right? In the same way that someone might talk about hypotheses or assumptions they made in their model, right? So I like to see that. From what we've seen with CFA just recently, number of chains can be important too, because it'll give us evidence that you didn't converge to the part of the distribution you don't want to converge to. But again, that's not always an issue, and so if the author explains why that wasn't an issue, I mean, that's fine too. So there's lots of ways to go about it, but in my particular article, they didn't say some things I was hoping to see, and they give me assurances that they didn't need to say that.
I think that's a good point. I like to think kind of a standard for me is if given your data and just the article, could they reproduce your analysis? That's a big point, right? And that's where relying on program default is difficult because let's say in another update of a program, the defaults have changed, right? Which may happen. It could happen a lot. Certainly in the R packages that happens, I think. But as people write programs more efficiently and so forth, things change, right? What do you think? Anybody else?
Actually, I got a question.
Yeah.
So when we do Bayes, I have a lot of graphs. We make very subjective decisions on that. You cannot include all those graphs even in the supplementary material.
Probably not. No.
So we can only make a statement in very simple words to suggest that we understand the convergence has been reached and we believe what we did is correct. But when you put those information, for example, number of iterations in the paper, it's more likely that people will challenge you about why do you pick this number? Why not bigger one? Why not smaller one? And all you need is just convergence. So
well, true, but I think you can list the number of iterations, and for convergence, what I take to do is I report the quantitative information. So if I have, like in our factor analysis here, we have 177 people, so it's 177 factor scores plus the model parameters. For each, I can run Gelman and Rubin on, on my multiple chains. I can get a Gelman and Rubin R for each, and I can talk for each type of parameter what proportion was lower than 1.1. I could also say things like, the largest Gelman and Rubin for any parameter in the whole analysis was 1.15, right? Something that would be indicative of convergence that wasn't just plot. So I think that's one way to get around it, that issue. But I do agree, more information could be harmful because people will ask why, but I think you can justify the number of chains by that. By a little bit of it. So you type change and convergence together. I think that's but you make a very good point about that. Thank you.
This was interesting. So in my article, we're talking about convergence. So we looked at trace plots. And maybe I'm just really cynical as a reviewer, but when I approach it, I'm like, I don't know if you know how to read a trace plot necessarily. And so I want more information. Clearly, you shouldn't give me all the trace plots, right?
Right, and all the Gelman and Rubin R for every parameter is going to be overkill as well. Yeah.
Right, but so talking about convergence is difficult, I think.
Yeah, but I think it's necessary.
Yeah, absolutely. But just saying, I look at pretty pictures, didn't cut it for me as a reviewer.
Yeah, you're right. I mean, you're right. There's some point where you can't look at all the pictures. I think you made a very good point. You can't, even in the supplementary material, if you have 3,000 parameters because you put random effects in or whatever, forget it, right? You're not going to go through 3,000 pictures. So, but I think my strategy has always been let's go talk about the maximum, the highest value of the Gelman-Rubin, or whatever the chosen statistic is. Gelman-Rubin shows up everywhere, so I just use it. But also beyond that, I can break it down by type of parameter as well. And I can even mention that there was a modeling. So a lot of times in the Bayes model, it's never straight through. There's a modeling process to understand that. So after several, trials of chain length, we settled on this. It converged, right? I think that's important. Right? What else? What else should be there?
From my experience, at least tell me what program you were using.
Yeah.
Like, don't just say I ran a Bayesian model. It's like, in what?
Yeah, exactly.
If you're not going to tell me the iterations or anything else, at least if you're using an R package with one, or
Plus.
using JAGs or using that plus, like, I can kind of make assumptions from there, but it drives me crazy when people just say.
I did Bayes.
Like, just cite where you did it.
Well, but
Estimator equals Bayes.
that's where you could just estimator equals template. Hey Jonathan, what do you think? What do you think this is? Oh man, I think that's a 3. highly confident in my result, right? highly wrong.
Using statistics.
The template estimator is shown to be biased.
Supposed to give him $50.
Not asymptotically consistent.
I also think the version of R package is also important.
Yes, also true. Yeah, you want to say what version of R, what version of. There's a lot of stuff you have to do. Why I'm building to this is effectively to really document your analysis well. You need to have that online supplement describing it. Ariel, if you're talking, I'm going to pick on you now. If you're Dr. Meta-analysis, Dr. Research Synthesis, which I believe you are.
I will print session info.
Session info.
So that will have the version of R, the version of the package, the whole.
That's good. That's good.
Because many times you have the same version of R, but you are running a different version of the package.
Yes, very true. What would you want to see if you come back as part of your as part of a meta-analysis? And I'm on shaky ground. I am not at all. Most of you will know more than me about meta-analysis. It's hard to know less than I know. I'm just going to say that out loud. So if I ask a very bad question, help me redirect it. But if you're trying to do a meta-analysis and you see Bayesian shows up in an article, what are you looking to see in addition about parameters that you might want?
Okay, let me ask you. In meta-analysis that is using Bayesian inference, while doing a meta-analysis and a primary study is using Bayes.
Yes, that's it. Primary study is Bayes.
In the primary study is Bayes. Oh God, I don't think that will sound crazy, but I don't think that I ever seen any in all the meta-analysis that I have done so far.
But you can anticipate some point in the future seeing those.
Oh yeah.
Because the influence of Bayes is coming.
Absolutely. I can say up to today, I can say crazy econometric stuff. I have seen silly stuff. I don't say I have ever called an article that was reporting Bayes inference.
Interesting.
Helen, have you?
Yeah. I've seen meta-analyses that use Bayesian techniques for performing the meta-analysis, but not primary studies that reporting any Bayesian.
No, my guess is like if I'm thinking aloud.
No, that's good. That's good. This is a good question. Yeah.
Compute the effect size as a standardized mean difference. My first intuition will go to look what they have, and I will run into seeing that it's a Bayes analysis. So I will look to see if I can rely in the unconditional means. Typically, I can. So then I will have to start digging into the output of the Bayes analysis to see how I can figure out some information to get a conditional mean difference, but unconditional standard deviations.
Interesting. Yeah. So you would need effectively for output each of the posterior distributions effectively, right? So it's just a question I think about. So when you think about writing an article, I don't think anybody writing their primary article thinks I need to write this so that someone with the meta-analysis can go and do a better job. Or do they? Maybe Ariel Bentley does.
It's interesting. In medicine, some sub-areas of medicine, people will do that.
Okay,
Because
that's good.
They don't look for their primary study. They want their primary study to be included in the next meta-analysis.
Oh, interesting.
So there are some, I don't think that it's all medicine, yes, but there are some specific areas in medicine that people will do that.
No, so yeah.
I will say I do write for that.
Oh, it's
I also
good.
do meta-analyses, and on the other side of it, of not having enough information.
Well, so this is another good piece of information. If you haven't taken a meta-analysis course, you should do. I'm pointing at Ariel. He offers research synthesis. Sorry, me. It's not. Or is that the name for it? Meta-analysis, research synthesis. Research synthesis and meta-analysis is the name of your course.
The course is research synthesis and meta-analysis.
Yeah, so I'm giving a plug for Ariel's course, but it's not just because it helps you understand meta-analysis. It also helps you understand how to write articles what information might be included as well. And I think so. This is where what I'm building toward is in an article in the text. You don't want to cloud the text with too much to have the reader go words, blah, whatever. You want to give enough detail to say, hey, I know what I'm doing. I looked at these things. I'm convinced, and I think you should be convinced that these results are to be taken seriously. But then having a supplemental material, having an online appendix where you even put the syntax in that you use, which would be fine, or you specify the priors for the distributions, also good, would be very helpful for it. So just something to keep in mind as you're doing this. But I thought it would be a nice thing to note as we're going through what all is needed, because there is a clash between readability of the paper and sort of documentation that's needed for belief in the result. And I think that's still there, even if we're not in Bayes. Any other thoughts? Okay. Yeah, Ben.
Just kind of a general question, but relates very directly to our homework. So, assuming I didn't screw up my model with the variance, I saw some autocorrelation with my variance. But my thinking was it was relatively a simple linear model, and I did a lot of replications, and I saw a good convergence according to the Gelman diagram. I wasn't too concerned about the autocorrelation that I saw.
Yeah, not usually something to be too concerned about. Autocorrelation is effectively an kind of efficiency of the chain statistic. And the reason that you probably saw the autocorrelation in the variance parameters.
Yep.
And the reason for that was it's actually you had to do some type of version of Metropolis to estimate them. And so you've got a very kind of a rejection sampling approach for those. And the autocorrelation is an indicator of how quickly you're rejecting values. Because if quickly you're accepting. If you reject, you have this, the same value in multiple steps. That's what's going to happen. So it's absolutely common. In fact, the examples I'm showing you to begin are probably way too rosy of examples. In most cases, what you're seeing for autocorrelation is even then is actually going to be pretty good. I think the autocorrelation, I think you mentioned, I can't remember, like 0.2-ish, 0.25, something like that. Is that
something like that, I think.
Yeah.
Now, autocorrelation could be an issue if you have convergent concerns, right?
Yes.
Because maybe you're in the wrong part of the distribution.
You haven't run it long enough to see that it might sample the whole posterior.
Yeah.
But in general, if you're getting the Gelman and Rubin, you're doing multiple chains, and you're running it long time, it should be okay. Other questions? Yeah.
So the authors in my article were running thousands of logistic regressions. Is there an easy or simple-ish way of evaluating that many models at once? Because they didn't report any results.
Wow. Yeah. Thousands of so what type of stuff? Like, are you looking to report the parameter values on each?
Yeah, like you can determine whether or not parameters have converged.
Yeah. See, I would look for like some summary statement about the Gelman and Rubin. Like, each parameter can have a Gelman and Rubin statistic, and you could just get just a simple proportion. How many of those were lower than, the standard is 1.1 is really good convergence. 1.2 I think is weaker but acceptable. I don't know where those thresholds are bad anyway, but something along those lines would be very informative, because you could say, okay, of my 10,000 logistic regressions, the fixed effect parameters were all all those parameters across all those, the 99 were less than 1.1. The highest was 1.18, something along those lines. Is that okay? That's a quick way to summarize it. I've had a number of students' dissertations end up being Bayesian. And I think that's the way that everybody settled on in the committees, and also when they try to publish it, for how to summarize things succinctly enough to get a good picture of it, but also, you want to say what the overall trend is, but also what the max, what's the worst looks like. Because if the worst is pretty good, then you're like, all right, it's going to be pretty good. So. Okay, how we doing? So that's like the conversation about homework. So I'm deliberately trying to slow down because I'm hearing this is a tough class, and I don't want to make it tougher. I actually want you to learn this material, right? I'm hearing this from multiple sources, multiple people. So is there anything about Bayes in general we just have a discussion about right now you might want to talk?
This might be a silly question. So if we have conjugate priors, right? So we know the posterior is from the same family. Can we sometimes not have to resort to sampling, but if that posterior has a known functional calculable mean, we can just calculate that mean, right?
Yes, but oftentimes in an analysis. So a good example of this. So let's once again posterior. Conjugate prior is one where the prior and the posterior have the same distribution effectively. They don't have the same parameters, but they'll have the same distribution. So a real simple case is like the very beginning, we did a beta binomial, right? We had a binomial piece of data, we put a beta prior on its proportion parameter, and then we ended up with a posterior that was a beta distribution. And in that case, we didn't have to sample, we knew what the mean is. Just a quick update, there's a math that went into it, but that was it. In a linear regression, we're using conjugate priors, but there's a dependency, right? The prior for the variance, prior for the fixed effects is conditional on the prior for the variance. And then if you think about how the sampling works in that model, you have to sample one and fix that parameter conditional on, to make the next part conditional on what that value is. And so that's what makes the chain have to move forward. There are other ways that you can create algorithms where you could, like a version of like an EM algorithm where you could do that, where you could say, here's a posterior mean, I'm going to go plug in the values of what that is. In fact, that's what EM is. If you think of the EM algorithm, back up. What's the EM algorithm? The expectation maximization algorithm. It's used in a lot of latent variable or random effects model. It's not as much in random effects anymore, but
you see it in IRT a lot.
IRT. And the way the algorithm cycles, instead of just trying to, it takes, it plugs in for everybody. Let's take an IRT model. Let's take a simple one parameter model, or one factor model. I don't care how many parameters. Let's take, Roche came down, no, never mind. Was Roche a Bayesian? Never mind. So you have one ability, let's call it ability since we're in education, and a bunch of item parameters, right? And so what the EM algorithm will do, there's an E step where you go and plug in the mean or the expected value for the ability, and then conditional on that expected value, you turn around and use essentially maximum likelihood and go and figure out the item parameters, right? If you had a 2-parameter model, you could really quickly shortcut the EM algorithm by plugging in a mean, and then conditional on that mean for each item, it's an independent logistic regression, right? And then you flip back and do the mean and do it. So what this is happening in, so you can, that's actually the E step expectation. It's an EAP estimate. You're using a Bayes result, the posterior distribution of theta, to plug that in. So there are cases where that happens. Now that's not even a conjugate prior. So you could develop algorithms that were similar to that. Why? No, I'm just kidding. But no, it's I think for maybe high dimensional problems, like when you really have a lot of computational issues, yeah, maybe that would work a little bit quicker to speed you to a different place. But typically the issue is not the conjugate prior. The issue is the dependency for parts of the analysis that have to be separate based on the model itself. Does that help answer?
Yeah, totally.
All right, other people, Bayes. What are things we can talk about in Bayes that might help you solidify little bits of understanding as we go along too? It's just me and my stomach growling. Nobody? We don't have to talk about anything. But should we go over? Would it be better served if we spent time going over what we did last week with CFA again, just real quick as a refresher, and then we dive into the new stuff? Okay. So the plan, part of this class, that some of the things you may be feeling when you're doing homework, is that it's necessarily insufficient to do anything complete with any of the topics. What I'm hoping is the repetition across the topics of factor analysis, IRT, and so forth, and psychometrics, or even linear regression, helps cement a lot of the Bayes things that we're doing here. So when you do your first homework, you're going to like, okay, what's this again? How's that go? Second homework's going to take a very similar feel, right? There's an analysis. There's an article, of course, but there's an analysis that you can do that's going to have the same features, just a different model. And then the third homework, once we get there, which still may be weeks away, it's going to be about IRT, right? And so that and the third homework is coming out. The fourth homework is IRT. The third homework is CFA. Those are going to look really similar because IRT and CFA are very, very similar when it comes to the model side. We changed the model for the data right here. It's no longer D-norm for IRT. Now you have an IRT model. There you go. So it's a little more complex than that. It depends on how many categories. But a simple binary IRT model, switch that to a Bernoulli, drop the error term from it, and next thing you know, we have an IRT model, right? So there we go. So let's do that. We have about 7 minutes or so before break. Let me go through what we did last time. This is that crazy data. I don't want to say crazy, but there's the conspiracy theory data. Remember that? Mm-hmm. Pretty intense stuff. I'm not going to plot. So we read in our data, and the first thing we did was to go run a single factor model. Remember that? So we did this. We're going to take 10 items overall. We're going to run the analysis with 4 chains. Each chain has 3,000 iterations, a burn-in of 2,000. And I like to see if we need to adapt our algorithm. This one, the first analysis, doesn't need adaptation because it's basically a conjugate prior analysis throughout. So these are the other specs. Now, the analysis itself, when you get into the weeds about factor analysis, conditional on the value for the factor, it becomes a linear regression, right? That's the thing to note. If you know F, like in a step in an algorithm, if you think of the algorithm as it's moving, when it goes and it samples F, and it's conditional F, it gets down to the item parameters. When you know the factor, you go to the item parameters. That step for the item parameters is identical. Like JAGS doesn't know if it's linear regression or factor analysis. Absolutely identical to linear regression. Right? So the basis for where we started with the parameters was where we started with the priors was sort of where we started back in the linear models part. And you know, my proclivity, I like having conjugate priors because that means the chains are very efficient. But I also like to have them be very uninformative. So an uninformative prior means something with a very big variance. So there's not a peak of probability mass somewhere that sort of moves the parameters over. So in the factor model, the factor analysis has a mean. For each item has a mean. In fact, let me switch. Bang. Actually, I could do this. Let's do some drawing, shall we? Maybe. You can't see this, can you? Come on, Jonathan. You note. There we go. This right here. So for each factor analysis, we say that y, our item, right? This is for a person and item, is equal to mu for the item plus lambda for the item times the factor for the person plus like this, right? So this, if you condition on F, if you knew what the factor score was, this would be a simple, very simple linear regression for each item. And that's kind of the basis for understanding where we're going. Then, so that mean for the item, this item mean itself, it's that mu parameter. We know that it needs to be, just looking at our data a little bit to pick our prior. In regression, I picked the prior where the beta mean was at 0. And I did that because 0 is sort of a null result in regression, right? So if I put a prior on the mean at 0, then all the betas, including the intercept, get pushed towards 0 by the prior, if the prior is informative. Right. So there's our mean. So we want to put a prior on this that resembles data. We know the mean, for instance. We know these items are all 5-point Likert scales, so the scores are 1, 2, 3, 4, 5. That means the mean cannot be bigger than 5 or less than 1, so long as we have a 0 mean for our factor.
Can I interrupt?
Yeah.
It's intercept, not mean.
Intercept, mean, mu.
No, it's only the mean given a certain model of identification for the factor. It's intercept.
Yes, factor intercept, I agree.
No, I found people get very easily confused by this, so it has to be intercept.
True. The item mean, I was drew on the other wrong thing. The expectation of YPI is the expectation of mu plus lambda f plus e, right? And if you work that through, right, you can pull out the constant, which equals mu. In this case, plus expectation of lambda f, and the expectation of error is 0. So in that case, if the expectation of lambda, the factor mean, is not 0, then the mean for the item changes. Yes. Thank you.
Yeah. Let's say, like, if you identify by fixing an item intercept to 0 and then estimating the factor mean, that mu is not the item mean.
I agree. I agree.
Right.
And I'm following notation that's sort of a standard issue factor analysis. So, agreed. Thank you. Appreciate it. But I'm identifying it with the factor mean of 0. So we know mu needs to be somewhere within the bounds of 1 and 5. Right? So then I pick a mean of 3, right in the middle of that region. So this is the prior mean for all those mu's I'm setting to be 3. Okay, so now you're like, okay, it's right in the middle. Aren't you going to bias things toward 3 then? Possibly. The next question to figure out is how big is my factor variance, or my prior distribution variance? And right here, the variance is 1 million. How about that? Is that an informative prior? No. No, if I were to plot the normal distribution with a mean of 3 and a variance of 1 million, within the range where I expect the mean to be, between 1 and 5, you pretty much see a flat line. Right? If you go out to maybe the 7th decimal place, you might see a little bit of difference between the 5 and the 3, or the 1 and the 3, but it's not going to give you a whole lot of information. Right? Now I convert that to precision because JAGS wants precision. Now for the factor loadings, I did create a different mean value for them, and I'm still going to apply the same logic that I applied at regression. And that is my factor mean, or the mean of my loadings, I'm going to force to be 0 for the prior, because that's effectively a null result, right? It's sort of, if I'm going to run my data and I have no idea about it, I feel like it's better scientifically to say, have the data overwhelm the prior when the prior is at 0, rather than say, oh yeah, I think the mean for all the factor loading should be 10. I've got really good items. I wrote them, so they're really good. Right? That doesn't make any sense. But so anyway, I do that, but I give it the same variance. I'm going to talk about unique variances for just a second, and then we'll have our break, okay? Now, unique variances, if we're looking at factor analysis as being, with conditional on F, being a linear regression, the same logic for setting the prior, so it's uninformative, for each of the regression parameters applies. The unique variance then I can set with the prior that we used before, we can use the conjugate prior, which is inverse gamma for the variance. Or if we flip that, once we get into JAGs, it's precision, not variance, so we have to do gamma. But the two parameters, alpha and beta, are the same. We tell it we have 1 degree of freedom. That's the least amount of information we can have that's an integer. And we tell it that the variance, as the maximum variance for a unique variance, is still bounded by the maximum variance for each item, right? So we're going to give it that as a conservative estimate. What's likely to happen is, this is again going to be very uninformative. If you look at the range of variance this prior would be over, it's likely to be a pretty flat line. There's not a pile of information at 0. So this should be a pretty uninformative. Everybody follow that okay? Questions? Let's take a break. Take a break, we'll come back, and we'll just follow through this analysis one more time, make it work.